Hey there, everybody. Thank you so much for joining us today. We are so excited to jump into this webinar with you all. We have some fantastic presenters. As you get settled in, I'd love to encourage you to navigate to your Zoom window. Right at the bottom of your Zoom window, you'll see what looks like a chat bubble and it says chat underneath. Please click that bubble and go ahead and set your to everyone so that everyone can see your chats. And go ahead and let me know, um, have all the leaves fallen in your area? If they do fall, I imagine in some areas they are still staying strong, but here it looks like our leaves fell truly overnight. Let's see. Someone's leaves have not fallen, not yet in East Tennessee. Wow, so it seems like Oregon is ahead of the game. Okay, Nancy says some have fallen, some trees have leaves in New York, some but not all, mid-Missouri. Kansas City oaks still have leaves. How fun. Let's see, some are still hanging in Kansas, leaves mostly falling, northern Ohio. No chance in South Texas. Very fair, Nadia, very fair.
I
Mostly
was
gone in Connecticut.
yeah. I was just in Sacramento where, California dream and all the trees are green. So
Man. Yep, not ready for winter, but enjoying the leaves and the fun, how pretty it is for now. To make the most of our time together today, I do just want to hop into some housekeeping items. I don't know if we have the housekeeping slide, Melville, if we could go to the next one. Perfect. First and foremost, a recording of today's webinar will be live on our website. It usually takes us about 3 to 5 business days to get that edited and posted, but as soon as it's live, it will be on our website and our YouTube channel. You will also receive a recording of of the YouTube link. So please make sure to keep an eye on your inbox. I'm going to drop a link to the resources folder into the chat as soon as I'm done talking. There will be a certificate of attendance in there, so make sure you grab that. And the last thing I want to mention is that we want to answer your questions. So please use that chat function and ask us your questions. Do just make sure that you are sending it to everyone so that we don't look like we are talking to ourselves when we answer your questions. That being said, I'll go ahead and pass you off to today's presenters. Thank you so much for joining us.
hey, thank you. So what we're going to do today is you're going to meet the presenters. I'm going to introduce you to the GoDirect Spectrovis Plus. That's our spectrometer. I'm going to show you a little bit about spectral analysis, how it works. And then but also really importantly, I'm also going to be talking about our Biorad and Vernier partnership and a lot of the labs that you can use with our spectrometer with Biorad and their kits, which are really great. But I'm going to be showing you the 3 different ways that you can use our spectrometer and another really cool different way if we have time. And then Damon is going to be talking about the different kits as I mentioned them. And once again, questions are welcome at any time. This presentation contains links and resources that can be really useful, so you should get access to that, but please interrupt us at any time if you have questions. So this is just a little bit about me. My name is John Melville. I have a BA in biology and psychology from Sonoma State University. I got my PhD at Oregon State. I did a postdoc at University of Oregon, but probably most important for this discussion is that I was an assistant professor of biology. Actually, and I also was an adjunct at Lane Community College, in addition to being an assistant professor at a small liberal arts college called Wartburg College. My big focus has always been on teaching majors and non-majors courses in biology, neuroscience, marine biology, etc. And I've had a really strong emphasis on all of my courses when I was teaching in active learning and data collection and inquiry. I also was the director of the biology department for about 15 years here at Vernier. So Damon?
My name is Damon Tai. I'm Biorad's curriculum and training specialist for the Western region of the United States. I've got a bachelor's of science in biology and chemistry from a small liberal arts down in the San Francisco Bay Area called St. Mary's. I used to teach high school in Portland, Oregon, and then ended up working on the Human Genome Project and a lot of large genome sequencing projects through the national labs for about a decade. And I ended up moving over to Biorad a little over 10 years ago, mainly because I was running into an issue where we would get these four-year grads that were really good at the theory and then not so great at the hands-on skills. And so I joined Bio-Rad to help kind of drive more of that synergetic learning into lower and lower age groups.
Cool. So the first thing that I want to do is just talk about our spectrometers. So Vernier has a whole bunch of what we call, or what we would refer to as go-direct spectrometers. You might have our older spectrometers that were called like the SpectroVis Plus. We also had an older UV-Vis. But the most common spectrometer that we have is that it's out there is this one right now, the go-direct SpectroVis Plus. Go-direct refers to the fact that this device can connect either via USB or Bluetooth. So it can connect to anything. That's why it's called go-direct. So it can be used on a Chromebook, Android tablet, iOS device, Mac or PC. We also have go-direct UV-Vises. So same thing, these are can be used either via Bluetooth, wireless, USB, and they can connect to any device, PC, Mac, Chromebook, tablet, even your phone. Well, I like to say that the SpectroVis Plus replaces a Spec 20, whereas the UV-Vis, it's going to be much more expensive because it has really good UV light all the way down to around 240. So this is a true UV-Vis. This is really much more of a visible spectrometer. It does report down to about 380 nanometers, but really there isn't a lot of great light there. So I like to say this is really a visible spectrometer. Both of these also have little ports in them where you can stick a fiber optic. So that's why the reporting range is a little outside the useful range when you're doing absorbance measurements. We also have two other spectrometers that you might be interested in. This is the go-direct visible spectrometer. It comes apart into two pieces. So this is the light housing right here, and this is the detector portion right here. This is what I would call much more like a research quality visible spectrometer. That's why it's much more expensive. The entire case is made out of metal. It's going to be a lot cooler, meaning if you have a solution, it's not going to be heated up by putting light through it, things like that. And so that's why it's more expensive. It's also going to be more accurate. We also have a go-direct fluorescent UV-Vis. This is the UV-Vis, the same as the last one, but you see right here, there are these little modules that you can stick in it that will excite at different wavelengths. Now, if you just want to just show the basics of fluorescence, don't forget that the SpectroVis Plus can do that too. It's got two LEDs that are integrated into it, so it can also show fluorescence. So this is what we refer to as sort of our entry-level spectrometer. It's great. It replaces a Spec 20 and has lots of other great features. And then we do have a true UV-Vis, a more what I would call like research quality visible spectrometer, and then the fluorescent UV-Vis spectrometer as well. I just wanted you to know that we don't just sell the SpectroVis Plus. We sell a whole family of spectrometers. But I'm going to be focusing mostly on the go-direct SpectroVis Plus. So any questions so far? Do any of you have our old SpectroVis Plus? It looks a little bit different, or do any of you have a spectrometer from us? Go ahead and tell me in the chat if you do or not. That'd be great. Don't be shy. Just type it in the chat and say, yes, I do. No, we don't. Great. So some of you do, some of you don't. Great. The thing about the SpectroVis Plus, okay, someone's got some older and newer. No worries. If you have the older one, everything that I'm going to be showing you is almost going to be exactly the same, except you can't use it over Bluetooth. You can't use it wirelessly. So the go-direct spectrometers, they can be used directly. You don't need an interface. It'll come with a USB port and a cable. It also has a Bluetooth radio. There's also a power supply that comes with it and a battery. You really only need to use the battery power or the USB power supply or the power supply on it if you're going to be using it wirelessly. If you're using it with a computer or Chromebook, just use the USB cable and everything's going to be slick and fast. But you can use it with your phone or iOS device or tablet through Bluetooth. It's got a really simple, straightforward calibration process. And now the software that you would use with this device is either spectral analysis. That can be used across any platform. So spectral analysis can be used on, like I said, a tablet, Mac, PC, etc. And it's free, doesn't cost anything. If you're using a Chromebook, pretty soon you won't be able to use our packaged app. So you'll just type spectralanalysis.app into the Chrome web browser and you can use spectral analysis that way. And if you want me to show that to you later, I can. Don't forget, it can also be used with a LabQuest. So if you have our old little handheld device called a LabQuest, you can also use our specs on a LabQuest. All right, so here's the big thing I think that I wanted to hit in this webinar, which is our spectrometers are quite a bit different than the Spec 20 in that they do an entire scan. So you can see the entire spectrum. You don't just pick a wavelength. But there are plenty of people that still just want to look at a single wavelength. So what I want to show you is all three modes. So you can do a wavelength scan, and then also you can look at a single wavelength. The two ways, typical ways in which you would look at a single wavelength would be maybe you wanted to create a standard curve. To do that, you would create a standard curve. You would just look at one wavelength, and then in Kinetics, you can track a single wavelength in real time. All right, someone asked, I knew someone was going to say it, is spectral analysis better than Logger Pro? Spectral analysis, it depends on who you ask. I'm an old school Logger Pro user. I love Logger Pro. People that are used to using spectral analysis probably think it's better. The more important thing that you need to be aware of is that Logger Pro is no longer under active development. And that means that when it dies and goes away, we won't be supporting it anymore. I have seen a few problems with our spectrometers in Logger Pro, mostly in Windows and stuff like that. So you should still just be thinking right now about switching over to spectral analysis. That doesn't mean things don't work. It just means that if something does break, we won't be able to fix it. So I would recommend just beginning to use spectral analysis, even though I love Logger Pro. All right, so let me just do a quick demo of how to use the spectrometer, show you how easy it is to use, and collect a single scan. All right, so I'm gonna let me launch spectral analysis. All right, so spectral analysis is launched, and then let me show you the spectrometer. There we go, there's the spectrometer right there. Let's see if I can do this together. Oh, they went away, hold on. There we go, so they're kind of next to each other there. All right, so I've got the spectrometer already connected over USB. You can see there's a little green LED on that says it's connected. You'll see down here below that it says, hey, I've got a Vernier GoDirect Spectrovis Plus connected, so it's all ready to go. And then all that I need to choose next is which mode do I want to use. So I could do transmittance, fluorescence, emissions. There's this really cool advanced full spectrum mode. But I would say 90% of people want to do absorbance mode. So if I tap on this little down arrow here, you'll see it'll say, hey, do you want to do a full scan? Do you want to do like Beer's Law, which would be a standard curve? Or do you want to do kinetics? So why don't we just do wavelength full spectrum? So I'll pick that. The next thing that it's going to do is it's going to say, hey, the lamp needs to warm up. It's really just 90 seconds, actually less than that, since it's already been connected. And so what I'm going to do here is just wait for it to warm up a little bit. And then I'm going to show you this right here. What I have right here is my solvent. This is 70% ethanol. And this is a very quick extraction of chlorophyll that I did with some spinach. But I could also show you red food coloring if you wanted to. I mean, that would not be hard to do, or something else. So let's see. All right, so I'm just going to put in my ethanol here. You can see I'm going to put it in so that it's lengthwise here with these semi-micro cuvettes. Other cuvettes might have stripes on the side. You want to make sure the clear part is facing each window on this side and this side. So I'm going to say skip, and I'm going to say finish calibration. Great. All right, and then I'm going to take out that, put in my chlorophyll extract, and then I'm going to hit the collect button. Whoa, it's off scale. So that's cool. So I would need to dilute this down, but that's a little chlorophyll peak right there and another one there. So let me hit stop. And that's a really cool thing to be aware of, is that the spectrometer is going to work best between 0 and 1. That's when it's going to be most linear in its response. So if something like this happens to you, it's really simple. All that I'm going to do is I'm just going to dilute this sample quite a bit. Here, and then let's take a look at that again. Oh, so that's a lot better. Let me take a look at another sample here. Let's take a look at this here. Those are not bad. Let me hit stop. And then, of course, I can also just get rid of the first data set, not show it there. And there we go. And what that should look like to you is a little bit like I mean, this is a very, very fast chlorophyll extraction I did. These are the chlorophyll A and B peaks. And that's also a chlorophyll peak right there. So that is just how quickly you can do a scan. You can do a series of scans over and over. Any questions on that? I mean, there are a lot of labs out there where you would just look at different spectra, like look at food coloring, look at spinach extracts, things like that. One of the things that I want to show you, though, is a very cool kit that Bio-Rad has. And I did this kit, I got it from Damon, and I think it's really cool. And if you are interested in doing any sort of bioactivities, biotech activities, this is a great one to use with our spectrometer. This is the size exclusion chromatography kit. You have these great little SEP columns. You wind up separating out hemoglobin from vitamin B12. It comes with everything that you need, buffer, you just run it through there, and you'll see the results that you get are just like this. You'll have a darker red color for the hemoglobin, and the vitamin B12 over here will be a lot brighter red. And I just ran this through our spec, and this is the data that you get. It's just gorgeous. So, right, so what I did is I just took 2 drops of the combined solution, threw it in 2 mils of buffer, and you can see that is the purple on this graph. So the purple here is both combined. And then I ran the lab as directed, just straight out of the instructions from Bio-Rad. And then I wound up condensing both samples on either side. The vitamin B12, which you can see gives you this green trace here. And then the hemoglobin is the red trace here. So I was able to clearly delineate, separate both of these, and then show them in the spectrometer. So this is an incredibly simple and straightforward lab if you want to show students how chromatography works, separation works, etc. You can also use it with different compounds. Damon and I have talked about this a bit. I like to separate out different compounds. So I use that same SEP column with something called phycocyanin. This is really just blue algae powder, or basically a cyanobacteria powder, spirulina powder. I just mixed it up in water. It turns blue, and I ran it through these columns. And you can see that there's this great big giant phycocyanin peak. And then as you run it through the column, it gets much more purified. You don't have this big giant baseline on it. Do you want to mention anything there, Damon, about the kit? You want me to go back to it?
I can kind of take from there. What I do like about this kit is the prep on this is super easy. It's literally pull the columns out, rehydrate the proteins or the vitamin B12 and the hemoglobin, and then like move on to doing the lab. Also, the other thing I like about this is that those columns, the resin is really stable. And so I have multiple teachers that will just restore it in the buffer, throw it in the fridge, and then be able to use this for a handful of years. So also kind of bang for the buck. I feel like this is a good one too. And then like John said, you can take this and you put not the stuff that came in the Bio kit on it and see if you can use it to separate, which is also a really great extension to do with this too.
Yeah, I want to reiterate what Damon said. because I just wanted to play around with this kit, and we had some SEP columns that had been literally sitting in the lab for 3 years, just in the back, hydrated, 3 years at room temperature. And I just went, I wonder if these will work. And I pulled them out and the experiment was great. So very stable, super simple, very straightforward. If any of you are interested in a short, brief write-up of how I've done what I've done, just email biology@vernier.com and I'll send you like a really simple, brief write-up. But it really was just 2 drops of the combined compound into the buffer that they give. Like, it's super simple, and then run it in the spec. But you just let me know. All right, questions on that? All right, so let's talk a little bit about kinetics and standard curves. Why don't we I'll do standard curves first. So I just want to give you a demo of what a standard curve is like. So for example, let me go back to my spectrometer here. Just do new experiment, don't save. So in this case, I'm going to do a different experiment. I'm going to choose concentration versus concentration of Beer's law. Go back to the view of the spec. In this case, what I've got is a series of standards. So don't worry about what these standards are. This is just colored blue stuff that we have at different standards. But these could be protein standards. These could be standards of pretty much anything. And what I'm going to be doing is creating a curve, and then we can find out the unknown. So in this case, I need to use water as my blank. So I'm going to recalibrate. And what I mean by that is whatever your solvent is that you're using in the experiment is what you need to use as your blank. So like if you were doing the Bradford assay from Biorad, which we'll talk about, you would want to use unreacted Bradford as your blank. All right, so I'm going to go back here before I go back to this. I want to calibrate, so I'm going to recalibrate. I'm going to hit skip and finish calibration. All right, so now I'm going to insert a sample, one of my standards. And there we go. Now it should see a peak. And what's great is I can either just tap on the peak, but even if once I tap on the peak, I can also just type the wavelength that I want. So if you know a specific wavelength that you want to track, or maybe in the Biorad instructions, it says it's a different wavelength, like maybe it says it's 635. Okay, that's slightly off peak, but you can do that. It's not a big deal. Or you can just choose the peak as is. So I'm going to hit done. See here, hold on. Let me change this graph a little bit for you there. And then all that I'm going to do next is I'm going to take out this and put in a new, another known standard. So let me just move this off to the side so you can see how this is created. And really all that we're doing is we're creating a standard curve. So I'm just going to hit collect. We want to wait for this reading to be stable. So I'm going to say keep. And I'm going to say this is 0.24. I'll put in my next standard. Some of you might be saying to yourself, hey, why is it in moles per liter? Why can't I change that? That's because this is the software was designed by a chemist. Most chemists are going to be doing it this way, but don't worry, I'm going to show you how to change it to whatever you want when we're done. So you can see that's stable. I'm going to hit keep. I'm going to say that's 0.32, keep point. Here's 0.16. I'm just waiting for this to stabilize. I'm going to hit keep. 0.16. So you should see that I'm beginning to just create this standard curve. Let me do one more for you. .08. Great. So that now I've created a standard curve. And now what I could do is I could go over here and I could say, go to my graph options and I could say apply a curve fit, hit apply. And now, I've got a curve on here. And now the big thing might be, well, okay, what about an unknown? So here's an unknown. I'll just put that in the spectrometer. And you should see that this reading right here, this meter reading is going to change. So the meter reading is always live. Okay, so it's at about 0.801 absorbance. So I could find that over here and we could then determine the concentration, right? Now you can do this any way you want. You could tell students, hey, there's the formula right up. There's a formula up there. 0.08 minus 0.32 moles per liter, that's the X range. The slope is 3.847. There's the intercept. You could have them do all of that, calculate the unknown. You could also just go over here and turn on interpolate. And then you can actually go along the graph and find it. So 0.797, right around there. So that's 0.2 moles per liter, which is basically what the concentration is. So this little experiment worked. But just to remind you here, I'm going to hit stop. You can change what's in this column. So after the fact here, I could go over here and I could go to column options and I could say, well, this wasn't really moles per liter. This was milligrams per liter. And there we go. Now the graph should be, if I get rid of this, I can then do a new curve fit. And now it's in milligrams per liter. So don't feel like just because you can go back in here and change it and make it the proper concentration if you want to later. Questions about that? There's a great lab that we do with Biorad. Let's go back to that then. The Bradford assay, or what's called the gut protein assay. And that assay is found in 2 of our books. It's found in our advanced biology book, but I really like the investigating protein experiment, which is in our investigating biology through inquiry book. You just need a Spectrovis Plus and then the gut protein kit. The gut protein kit comes with everything that you need. And I'll let Damon talk a little bit about how the Bradford assay works. Is that okay, Damon?
Yeah, that's fine. So the Bradford assay works by having this reagent that's known as kind of COMASI, more or less, in there. And this reagent will bind to things like tryptophan and these other aromatic R groups in amino acids. And when it does that, it causes a shift in the absorbance. And so if you're kind of looking at Bradford unreacted, it's kind of this brown color. And then as you increase the amount of protein that it has access to, it'll shift into kind of the blue zone as far as the reagent looks visually. And you can then detect that using the spectrophotometer. What I like about it is that it is super fast, easy to use. And with the way Biorad ended up making this kit, I mean, if you buy one kit, you're going to have enough to run this with multiple sections, if not multiple years. The only really limiting reagent there is the standards, which are some BSA. But even with that, even with the amount that they give you, I usually find I can get about 4 sections or 4 periods at least out of one kit, which is good to know.
Yeah, I really like the kit. I mean, this is just showing once again that the Bradford assay uses it comes with a set of standards. Let me show you that. It's pretty nice. So, I mean, the kit comes with this really super cool, nice set of standards. They're all nicely labeled.
And color-coded, which is nice when you've got them all out on the table.
Yeah, and by the way, Damon and I have done an entire webinar on this kit that you could find on our website. So if you wanted to see like us do the entire thing, we've done that before, and you can find it on our webinar list on our website. Another thing that I want to talk about is in the inquiry-based part of it is you can do things like look at non-fat milk, soy milk, rice milk. So you can do different comparisons, which is really great. It's like you can buy a replacement kit as well. Like I said, Damon said, it can serve up to 320 students. We also even have an adaptation of it that looks at nut milks. So you can do things like take almonds or look at almond milk, soy milk, or even make your own nut milk, which is super simple and great and easy to do. So any questions on that? Pretty straightforward. All right, so the next thing that I wanted to talk about is kinetics. So enzyme kinetics is a big deal. Everybody likes doing kinetics. You can do a lot of enzyme kinetics with our spectrometer. I think what a lot of people might not know is you can actually track the wavelength in real time. If you're like me, I was used to using a Spec 20 where I would put the solution in the Spec 20. The students would, start their timers and then, they would put it back in at, 1 minute and write it down, and then at 2 minutes. And then we would assume that the reaction rate was linear, and we put that in Excel and, plot it. What I found is that the spectrometer, the Vernier spectrometer, makes all of that easier. And in a lot of cases, we're making a lot of assumptions about enzyme kinetics because of how we are measuring it time-based. So I just want to give you a quick example or demo of how kinetics could work using spectral analysis. So let me just start over again here. So in this case, what I'm going to do is I'm going to be using some red food coloring. So the thing to think about here is I can either make the solution either needs to get darker for a kinetic reaction or it needs to get lighter. For any of you that have done the DPIP lab before, it's commonly called the chloroplast lab. You're using this blue solution and you put in a chloroplast extraction and then it gets clearer. That is in a way an enzymatic reaction. There are also other reactions that make things darker. There's a standard peroxidase lab that a lot of people do, a guaiacol lab, and it gets darker over time. But the big thing is you're tracking it as a function of time. I'm going to put this red food coloring into the spec and move that out of the way really quick. Hello here. Let's see, let me do experiment. All right, hold on. I'm going to close spectral, start over really quick. Oh, let's pick kinetics. Then it'll ask me to do another blank. All right, so let me just disconnect and reconnect my spectrometer.
Well, John's doing that. One of the things I just want to highlight, because I used to do a lot of spectrometry back in the day and help like employees do it. And a lot of people just didn't have a good idea of how we even arrived at the number sometimes of where to be reading at. And this is one of the things I think when I first saw Vernier's spectrophotometers, I was just like, oh, this is so nice, because I won't even tell the students what we're going to do the absorbance at. I will ask them to find it by running through and seeing that full spectrum view and then having them pick. And I think it's really good to get students in the process of how do I come up with where I should even be looking. And spectral analysis does a fantastic job at that. Especially even now with the spectral analysis, a little color bar on the bottom, because it kind of gives them a reference of reality check. Like, that's kind of the spectrum I'm seeing. Yep, that's what I would expect. Great, there it is.
Oh yeah, no, it's great. So let me see if I can launch. Let's try the. All right, well, don't know why it's not seeing it this moment. We'll move on here. So you can track kinetics in real time if you want to. I'll come back to that here in a minute if we have time. But there's a different lab that Bio-Rad had that's really cool, that actually looks at biofuels. And in this case, what you're doing is you're looking at enzyme kinetics, but you're doing what we call a stop reaction. So what you're doing is you're setting up the reagent, the enzyme reagent, you're letting it go, the reaction go for a specific amount of time, and then you wind up tossing in something that's going to stop the reaction. And then you look at the absorbance at like 1 minute, 2 minutes, 3 minutes, 4 minutes, and then you can create your own kind of standard curve that'll take a look at that. Do you want to talk a little bit about the biofuels lab, Damon?
Yeah, sure. So what we're going to look at in the biofuels lab is a class of enzymes known as cellulases, and more specifically, this kind of end of the protocol use one when you're converting biomass to sugars, which is called cellobiase. So it's basically going to break the last dimer of glucose molecules. And if you're to try to actually observe this, it's pretty frustrating because glucose is clear in solution and cellobiase is clear in solution. And so you'd need really high in like kind of spectrophotometry or even more than that in order to be able to kind of watch this in real time. And so during the early 2000s, when there was a lot of investment in biofuels research, somebody found a great analog to cellobiase that's basically glucose bound to p-nitrophenol. And when that bond gets broken, you get free p-nitrophenol that in a basic solution now can give you a yellow color change, which makes it easier to monitor. But it means that you need to switch the pH to get that to happen. And so that's part of the reason why this is used as a stop kind of motion kinetics. So you'll add a base to pause the enzyme out, but then also give you the resonance structure of p-nitrophenol that allows you to get that yellow color. And that's what we're going to detect using spectrophotometry. And so it's a really slick lab for that. And what I really like about it is it's got an enzyme from industry that you can use, which is great. It's nice to always have something to lean into. But you can also have students go out and do bioprospecting, find their own cellobiases from fungi, from compost, whatever, and then actually figure out kinetics based upon stuff that they're bringing in.
Yeah, it's a great lab. There's 2 different versions of this lab that are listed in our introduction in our Investigating Biology Through Inquiry book. One is just a basic introduction to biofuels, which you can use as a basic introduction into enzyme kinetics. And then another one, which is more of the prospecting, which I really like. This is just a graph that shows you what that stop reaction would look like. You're putting in, you look at the reaction, the absorbance at different time points, and you can see that at different pHs, right, this enzyme is very pH dependent. At a pH of pH 8.6, the reaction really didn't occur at all. You can also look at the evolution, what we call the evolution of cellobiase in fungi, and then compare different fungi. Different fungi specialize on wood, others are more generalist, and some are mycorrhizal or symbiotic. And it's super easy to look at that because you can get all sorts of mushrooms today in a grocery store or buy them. So you can also look at the ecological niches that different mushrooms would have. So that's another activity or really cool lab that you can look at.
And one thing to know within that too, you don't necessarily have to have fresh mushrooms. It's always nice if you can, just for the students to interact with, but you can get dried mushrooms and just rehydrate them. And those enzymes are just amazingly rock solid.
Yeah. And like I said, this dried mushrooms work great. You don't need fresh mushrooms. So yeah, it's also in our Investigating Biology Through Inquiry book. So in the time that we have left, I got spectral analysis back up. Let me just give you an example of how to do kinetics in real time. I have some red food coloring that I've put in the spectrometer. I am just gonna select 520. I'm gonna hit done. So now I'm looking at the absorbance at 520. And then all that I'm gonna do is I'm just gonna take a teeny little drop of bleach and some water, put it in the cuvette, mix it up really briefly. And then hit the collect button. And then what we should be seeing is you can see the wavelength, the absorbance is going to just decrease in real time. So that's what I mean by tracking it in real time is, it's been 12 seconds, 14 seconds, the absorbance is going down. And then at the end, right, we could fit a curve to it and actually measure the rate of the reaction, which I could show you. Well, I think we're like 5 minutes out from end of time. Does anybody have any questions? Okay, questions? Go ahead and type it in the webinar chat and I'll be able to answer. We'll try to answer your question. Other questions, issues? Okay, so someone asked, can you still add a tangent line? Can you look at RFP and GFP? You can do UV GFP using our fluorescence. I don't know, Damon, can they look at RFP? There is a 400 LED. I don't know if they could look at RFP.
You should still be able to excite RFP with that. Yeah.
Yeah, so we weren't able to show fluorescence, but we have a 400 nanometer LED, which works great for UV GFP. And then we also have another one at 500, which would work for GFP. Oh, do the mushrooms have to be chemically prepared somehow? Do you want to?
They're just going to go through like a standard kind of grind in a buffer that Bio-Rad's provides that helps you extract proteins out and just kind of keep them stable. But I mean, to be honest, like it's practically grinding them in water because they are so just robust. But there's a buffer for it.
Yeah, and like I said right here, someone asked, can you do a tangent line? Yes, you can do a tangent line so you can get the instantaneous rate of the reaction. You can also highlight and select a region and then apply a curve fit and get the rate that way as well. So there's two ways to look at rates. What is the best way to find the reference absorbance wavelength? That's a really good question. It's really going to depend on the protocol, but in a lot of cases, most of these kits will tell you what it is. Like, so if you get the Bio-Rad kit for the Bradford reagent, it's going to say, hey, you should be tracking it at around what, Damon? Is it like
595?
595, I was going to say around 600. For the biofuels kit, if I remember right, it's around 405, 408 for paranitrophenol. So it'll tell you. And then what's nice about using the Spectrovis Plus is you make the reaction, you can put it in the spec and you can find it for yourself. So it'll be very clear what you want to track. But most of these, what we call colorimetric assays, they're going to tell you what you need to track or what wavelength you should be close to. How long could we track the wavelength? As long as you want. You don't set up any tracking or anything. You basically just tell it to go and it will collect 1 minute, 2 minutes, 10 minutes. Is spectral analysis software different from the graphic? Yes, spectral analysis is different than graphical analysis. So if you go to our website, let me just go to vernier.com here pretty quick. If you go up here to downloads, you will find what we call what I refer to as our 3 new real sensor companion apps. Graphical analysis is what you would want if you've got a temperature probe, gas pressure sensor, other stuff. And the majority of what you're going to be doing is time-based and it's sensor-based, like a gas pressure sensor or pH. It can also do event-based data collection. But if you've got a spectrometer, you want to use spectral analysis. It's going to be specialized for that. And then if you have our other instruments, let's say you have our GC, or maybe you have our polarimeter, you would want to use instrumental analysis. Other questions? So yeah, the software is different. Does anybody have Chromebooks? Let me just show you this really quick. If you've got a Chromebook, all that you have to do is type in HTTP :// spectralanalysis.app. And that's going to launch spectral analysis. So so that's another thing, is that you don't even have to actually install the software to run it. This will run on a Mac or a PC or a Chromebook. Can you print the data straight from the spectral analysis program? No, and that's but that's not really that big of a deal, because what you can do is you can just grab the data and copy and paste it out into Google Sheets. You can export if you wanted to, but you can also just grab a screenshot, export as a PNG, etc. But if you want the actual data, it's going to be fastest to just come over here, tap on the dataset column, and then just copy it and paste it into Google Sheets or Excel. All right. Other questions? Thank you so much for coming and listening to us on this Monday, which later in the evening, or 4 o'clock for those of you that are still teaching. Go ahead and please give Dylan feedback if you can on the webinar. And if you have any other questions, we'll hang out here for a few more minutes. Please feel free to ask and we'll answer them. If you ever need to get in touch with us, you can always email biology@vernier.com and just say you need to talk to Melville, and they'll send that to me. And Damon, how can they get in touch with you?
I will drop it in the chat since mine's very long.
Oh, I didn't say there were 2 levels of the book. I said that for the biofuels experiment, there are 2 experiments in that book. One that is just basic enzyme kinetics, and the other one that looks at ecological niches and stuff like that. So there's 2 different activities you can do in the book with the biofuels activity. Oh, and by the way, if you need to get any of these lab books, or you want to try them, you can always get a preview of them. Get in touch with me. Maybe you just want to look at 1 or 2 of them. Don't worry about buying the book. Just get in touch with me and I'll send you the instructions. 1 set of experiments is not a big deal. Please feel free to get in touch. Some of these labs will also work with colorimeters. So if you have our older colorimeters, they will also work, but we wanted to focus on the spectrometer because they're all designed to work with the spectrometer. But if you have colorimeters, let me know, get in touch, and we can help you out. Oh, and by the way, last thing, we're going to be at NABT this week. And I think Damon is actually going to be doing a lab using the Bradford, and I will be there helping him out. So if you're going to be down at the National Association of Biology Teachers in Anaheim this week, Thursday night and Friday, we will be there and you can come say hello.
All right. That reminded me, I wanted to let you all know that it will likely be more towards the 5 business days editing range, since we will be at conferences this week. So probably expect the recording more towards the beginning of next week. All right, I'll go ahead and end the webinar. Thanks, everybody.
Thanks, everybody.